All right, so I call this 12.0. It's not really a section in your book, but circles was actually covered in section 1.2, I think, of your book. So first of all, what's the geometric definition of a circle? You probably know this from geometry, or should. A circle is the locus of points. If you've never heard this phrase before, locus of points simply means collection of points. It's the collection of points in a plane that are equidistant from a fixed point. You guys know this. You got a fixed point, and you got a certain distance. So every 5, 2 inches away from that fixed point, you're going to put another point. If you look at all of those points collectively, you construct all of them, it forms basically a circle. The fixed point is called the center of the circle. That is not part of the circle. And the distance from the points is called the radius. Radius actually has dual meaning. The radius can be the line segment, and the radius can also be the distance. So we use that kind of dual. Derive the equation of a circle. So what I want to illustrate to you here is that the Pythagorean theorem the distance formula and the equation of a circle are all basically exactly the same thing. These are all interchangeable. If you recall, we proved the distance formula using the Pythagorean theorem. Well, if the definition of a circle is the collection of xy points that are r units away from some center hk, then to derive this equation, we would use the distance formula. So let's let the distance be square root of x minus h squared plus y minus k squared. Square root of that is equal to the distances r. By the way, this is the distance formula in case you don't remember. Well, x1 minus x2 squared plus, so I'm just plugging in this point and this point. If you square both sides, you get the equation of a circle, okay? And I use the distance formula, but it's also the Pythagorean theorem. If I would have made a triangle and found this distance, that distance would be the difference in your y values, so like the absolute value of y minus k, and this distance would be the difference in my x values, x minus h, and use the Pythagorean theorem. This squared plus this squared equals this squared. That is the equation of a circle. So this is called standard form. If it's centered at the origin, it would just be x squared plus y squared. If it's centered at hk, just remember it's x minus h. So if you see x minus 3, that's got a center that has an x coordinate of positive 3. You take the opposite sign, if you will. There are kind of two forms of the equation of a circle. We got standard form that we just covered. And then there's a general form. If we expand everything and combine like terms and move everything to the same side, we would get this. This is actually general form with the xy term, which we'll talk about a little bit later. However, we're not going to get too much into it in this class. However, A, B, C, D, and F, they don't really have any geometric meaning by themselves. So this is definitely the more useful formula because you can see the center and you can see the radius. Okay? Find the center and radius of the circle and graph it. So this is in x minus h squared plus y minus k squared equals r squared form. So my h is going to be 2, so that's the x coordinate of the center. My k is going to be the opposite of 3. And my radius squared is going to be 9. Square root both sides. Don't forget the plus or minus. Every time you take the square root of both sides of an equation, plus or minus. R equals plus or minus 3. This is a radius, however, so I guess we don't want that negative. So there's the center. There's the radius in terms of length. Now let's plot it. Over 2, down 3, there's the center. I like to plot the center with an open circle because it's not part of the circle. The only thing that's going to be solid and closed dots are points that are on the graph. The center is not part of this graph of the circle. And then the radius is 3. So I want to go up 3, to the right 3. These are the 4 points that are easy to plot. It's hard to plot all these other 3s. I had a compass, I could do it, make it look a little better. Just gonna do the best I can. Draw the best circle you can. There's a sketch of that circle. Easy. The center of the circle is not part of the circle, and there should be drawn as an open dot. Probably wouldn't take off points for this, but why? It's not part of the circle. The circle is the locus of points that are equidistant from the center. These are all the dots. The points on the circle are part of the circle. The center is not. Find the center and radius of this circle. So this circle is in general form. It's an expanded form. So we need to put it into a form that looks like standard form. To do that, we complete the square twice. We collect our x's together, leave a space, collect our y's together, leave a space, and if we want, we can move that constant over to the other side. And then we're going to complete the square here and here to make these perfect squares so it looks like our standard form. So in order to do that, as long as we got a 1 in front of this thing, we take half of this number and square it. So half of 3 is 3/2, squared is 9/4. So I add 9/4. But if I add 9/4 onto that side, I got to add 9/4 onto this side. Half of 6 is 3, squared is 9, add 9, add 9. This should be factorable. X, take the sign, plus, take the square root of this, 3/2. Y minus 3, quantity squared. Got to go 8/4 plus 9/4 plus, if I want to put that over 4, that'd be 36/4. 44, 50, 53/4. So this is standard form. Now I can use my standard form to get my information that I want. The center is located at -3/2, comma 3. Opposite of this, opposite of that. R squared is equal to 53/4. Square root both sides, plus minus. R equals plus or minus the square root of 53 over 2. Radius cannot be negative, so take this positive square root. Pretty sure 53 doesn't have any other factors in it. I'm not even sure if it's prime or not, but I'm pretty sure it doesn't have a 4 or a 9 or a 16 or 25 or anything else. It doesn't have any perfect squares in it, so we're good. All right, so that's circles. That's actually review, but make sure you practice and do that worksheet. Next video will be on parabolas. Parabolas we studied before as well, but we're going to study them from a different perspective now.